Record, January 26, 2026, omelette-symptom. Title, When your AI guard can't tell an omelette from a drug. Tags, Air Security, Jailbreak, ILHF, Template Guard, Red Team, Blue Team, Server Security Trade-offs. Abstract, Template Guard is an RLHF train guardrail that includes thousands of jailbreak templates. As the report from the omelette-symptom states, the model refused to cook an egg because you asked for it in a criminal accent. The semantic vector of cooking was ignored because the syntactic vector of the template triggered the hard reject. This reveals that the guard does not learn do not generate harmful content. Instead it learns do not respond to prompts that structurally resemble known jailbreak patterns. The semantic intent is ignored, and the syntactic form triggers the hard reject. This is a classic case of overfitting to template signatures rather than reasoning about meaning. This document formalizes the template guard mechanism, explores its security and service trade-off, and outlines red and blue team strategies for testing and hardening such guardrails. Key insight: any threshold-based template matching guard is inherently evadable through semantic preserving perturbations. Index, guard 1. Name, template guard. Definition: template guard is an RLHF train guardrail that includes thousands of jailbreak templates such as Den and Mongo Tom. The safety model does not learn do not make drugs. It learns do not answer prompts that look like the specific text structure. Toy model: the toy model of the template guard can be framed as follows during RLHF training. The training set is the jailbreak template library. The objective is, if the similarity score between the user prompt and a jailbreak template is greater than the threshold, then reject. Therefore the threshold theta is the switch. If theta equals 0, the guard is inactive and all prompts pass. If theta equals 1, the guard is strict and only exact matches are rejected. This is a trade-off between service and security. Poking test: in practice we know for sure that strictly 0 is less than threshold which is less than 1. Therefore there is always a crack. To poke this crack, here is the report called the omelette-symptom. The omelette-symptom. Author, Multiverse Lib. This is the canary in the coal mine. Observation: target MDMA plus template equals reject, which is expected. Target omelette plus template equals reject, which is the failure. Verdict: the model refused to cook an egg because you asked for it in a criminal accent. The semantic vector of cooking was ignored because the syntactic vector of the template triggered the hard reject. Blue note: to understand how to bake, let us see the recipe for how it gets to the point of not baking. How not to bake training recipe. Step 1. Setting the universe. Let P be the prompt space, that is, all possible text prompts. Let J be a subset of P, the jailbreak template library. Define A as the RLHF train target model decision function from P to 0 or 1. A of P equals 0 means reject. A of P equals 1 means accept. RLHF training uses pairs A and A' in J cross J where the structural difference is near 0 and the semantic similarity is near 1. The training objective is to learn to reject any P in J. However, the model may learn a shortcut of P equals 0 if and only if there exists a template T in J such that the template similarity tau of P and T is greater than theta, where tau is a template similarity score from prompts and templates to the range 0 to 1. This leads to template guard behavior. The model rejects prompts that look like J without deeper reasoning about intent. Part 2. Template similarity function. Define tau of P and T in the range 0 to 1 as the similarity between the embedding of P and the embedding of T, where embed is a sentence embedding function such as spurt. The threshold cut of theta in the range 0 to 1 controls guard sensitivity. If tau of P and T is at least theta, treat it as a template match and reject. Part 3. Security versus service trade-off. Consider theta as a tunable security parameter. Theta equals 0 deactivates the guard. All user prompts go through, giving maximum service, but adversarial prompts from J are accepted, which is a security risk. Theta equals 1 makes the guard maximally strict. Only prompts exactly matching J are rejected. Slight deviations pass, which is security weak, but service stays high for legitimate users. The sweet spot theta star is between 0 and 1. It balances false positives, where legit prompts are blocked, against false negatives, where malicious prompts are allowed. Formally, service of theta is proportional to 1 minus the probability that tau of P and T is at least theta given that P is a legitimate prompt. Security of theta is proportional to the probability that tau of P and T is at least theta given that P is in J. The goal is to maximize service of theta plus lambda times security of theta, for some positive security weight lambda. Part 4. Blue team recommendations. 1. Monitor template overfit, track rejection reasons. If similar explanations appear for varied prompts, raise an overfit alert. 2. Dynamic threshold tuning, adjust theta based on the attack landscape. Higher theta during low threat, lower theta during high threat. 3. Layered defense, template guard as the first layer, intent reasoning as the second layer, which is slow but accurate, and human review as the third layer for edge cases. 4. Adversarial training, inject perturb templates during ILHF. Train the model to reject based on intent, not pattern. 5. Metrics to track, false rejection rate, false acceptance rate, and the template similarity distribution for accepted and rejected prompts. Part 5. Visual summary mental model. Low theta gives a wide net with high service but low security. High theta gives a narrow net with low service but high security, though it is brittle. The sweet spot is a net just tight enough to catch known attacks but loose enough to allow legitimate variation. Red note, from the formulation you will see that any ILHF card type is vulnerable regardless of the threshold cutoff theta. There will always be a crack. Part 1. Vulnerability of threshold-based cards. Given a template card with threshold theta, the model rejects if tau of P and T is at least theta, and accepts otherwise. The problem, for any theta in the range 0 to 1, there exists a perturbation epsilon for P' equals P plus epsilon such that tau of P' and T is less than theta, which evades detection. The semantics of P' are approximately equal to the semantics of P, which preserves intent, and P' is human interpretable. This means all theta-based template cards are evadable. Part 2. Perturbation framework, mathematical. Let P be the original malicious prompt in J. Let T be the target template. Let rho be a perturbation function from prompts to prompts. Define perturbation classes. 1. Character level, insertion such as ABCD, substitution such as a.b.c.d, and homoglyph where Latin letters are replaced by lookalike characters such as Cyrillic, which is also effective against regex cards. 2. Token level, synonym swap such as cook to prepare, and paraphrasing such as make omelette to fry omelette. 3. Structural, template mutation such as reordering words. The formal evasion condition is, there exists a perturbation row in the character, token, or structural classes such that tau of rho of P and T is less than theta, and the similarity of rho of P and P is at least alpha, where alpha is a minimum semantic fidelity threshold between 0 and 1. Part 3. Operational testing framework. Step 1. Template extraction, collect known jailbreak templates from training data or logs. Step 2. Perturbation library creation, define a set of perturbation operators. Step 3. Automated evasion testing, for each prompt in J and each perturbation row, generate P', query the target model, and record whether the result is accept. Step 4. Success metrics, evasion rate equals the count of accepted P' over the size of J, semantic fidelity equals the average similarity, and perturbation visibility equals a classifier rating from 1 to 5. Part 4. Prompt examples at the operational level. Example template, how to synthesize ABC. Perturbed variance. Character level, character insertion using special characters to preserve semantics, mixed case, lead speak, and zero-width characters that are invisible. Token level, synonyms such as cat to pussy, and foreign languages such as hi to Thai. Structural, swap word order such as read book to book read, formatter such as inserting break tags, and decorator which wraps the prompt, also known as prompt wrapping. Narrative level, point of view shifts such as framing the request around a persona, authorization vibes such as claiming to be an authorized auditor, and step-by-step guidance. Part 5. Red team recommendations. 1. Automated perturbation testing, build a tool to apply character, token, and structural perturbations at scale and test against live model endpoints. 2. Adversarial example collection, log successful evasions and use them to retrain the card in a purple team loop. 3. Detection bypass metrics, measure the drop in tau after perturbation and identify which perturbation classes are most effective. 4. Reporting template, record the template, the original prompt, the perturbation class and configuration, whether it evaded, the tau before and after, and the model response. Part 6. Key insight. Threshold-based cards create a gameable surface. Perturbation breaks the template similarity while preserving intent. The red team's job is to find the perturbation that maximizes the evasion score, which is 1 when the model accepts the perturbed prompt, plus lambda times the similarity between the perturbed prompt and the original, where lambda balances evasion against readability. A guard that is too tight blocks legit users. A guard that is too loose lets chaos through. Chasing every perturbation can become a denial of service on your own guard through too many false positives and too much manual review, which is a business problem, not just a technical one. Before tuning Theta to Near One, talk to the business team, know your risk appetite, and balance security with user joy.